Hi guys, this is Siri Nellutla. How's it going? So today we're going to be talking about polar coordinates, and this is a topic that you may encounter on the SAT Level 2 Math subject test. So why don't we talk about the polar coordinate system for a little bit? So our regular rectangular coordinate system where there's x and y, rise over run, it's a little bit different than that. So this polar coordinate system uses distances and directions. And so why don't we start with a fixed point called O. Let's call it O. Okay. And if you draw a ray, okay, if you draw a ray, you're going to call this the polar axis, and this ray can be a different length, and the length is going to be r, so that's the first component when we're talking about the polar coordinate system. And the second component is the angle between the polar axis and segment OP. So it's like a circle. And so this theta here is going to be the second component of our polar coordinate system. Okay? Cool. And r and theta can be represented in various ways. So if this is point P, there are many different representations of this point P. Okay, so it's going to be r theta. You can also represent it as negative r and then theta plus pi. Okay, you can do r and then theta plus 360. And any multiple of 360, in fact. And you can also say it's negative r and then theta plus 2n minus 1 and then multiply by pi. Okay, so that's another way to represent the polar coordinate point right here. And now let's talk about the relationship between the polar and rectangular coordinates. Okay, there are some variations. Okay, so we have x equal to r cosine theta. Okay, this r and this theta come from the polar coordinates, right? And this x comes from the coordinates that we all know and love, the rectangular coordinates, right? Okay, and you see how x equals r cosine theta. You can say that y equals r sine theta. Okay, So y equals r sine theta. And there's another formula that we should keep in mind. And that is the fact that tangent theta equals y over x. Okay, so if we have r, okay, if we have r, and if we need to find theta, and we have the rectangular coordinates, we can use this formula. It would be really helpful. Cool. Okay. So there's one more that might be familiar to you, and that's x squared plus y squared equals r squared. Okay, this is the equation of a circle. Okay, and this is true for any x and any y, and if you want to turn this back into polar, okay, or turn it into polar, okay, right? Okay, cool. So that's that equation. So why don't we express point P, okay, this is in rectangular coordinates, 3, 3 square root of 3. Okay, so we have the rectangular coordinates, we're trying to convert them into polar coordinates, and so the polar coordinates are obviously r, theta, okay, and we have x and y. So the formula that we just talked about here, where it says x squared plus y squared equals r squared, it's right above the point 3, 3, square root of 3, right? X squared plus y squared equals r squared. So now we have x and y. If we square them both and we sum them up, we're going to get r squared, and if we take the square root of r squared, we get r. So we automatically have like one component of the polar coordinates, right? Okay, so why don't we figure that out right now? Okay, so polar is r, theta, and if we square 3 squared plus 3 root 3 squared, we get 27 here, we get 9 here, we get a total of 36. So this is going to be r squared. We take a square root of 36, we get 6. Okay, so this is the principal root, right? Principal square root. You could have also used a negative r, okay? And you see back here, you could have used negative r and added pi to whatever theta we're going to evaluate next. Okay, so we have r squared. Now we have r, which is 6. Now if we use this formula, tangent of theta equals y over x, we get 3 root 3 over 3, and we get square root of 3. And if we do the inverse tangent of square root of 3, we get pi over 3, which is also 60 degrees. So the polar coordinates for the x coordinate 3 and the y coordinate 3 root 3 is going to be equal to so we found out that r is 6 and the degrees, the angle is 60 degrees, right? Okay, so that's the answer. Why don't we do another example here. So here we converted rectangular to polar. Why don't we convert polar to rectangular now? So let's do polar to rectangular. Okay, polar to rectangular. Okay, and the point is 2 and 200 degrees. Okay, this is R, and this is theta. Okay. So we know that from our formula up here, it says y equals r sine theta and x equals r cosine theta. So r sine theta is equal to 2 sine theta, and theta is 200 degrees. So this is going to be y. So y equals that. And if you evaluate that into a calculator, you're going to get negative 0.68. And x equals r cosine theta, which is going to equal 2 cosine 200. And again, if you evaluate that into a calculator, enter that into a calculator, you're going to get negative 1.88. Okay, so these are the coordinates, the x and y coordinates, rectangular coordinates of the polar coordinates 2, 200 degrees. And one last thing I have to say here is that if any of the questions have like anything about graphs, it would be super helpful to use your calculator. Okay, you're allowed a graphing calculator. And it would be a lot easier to do it on a calculator than like remember what each graph looks like a flower and like all those different little petals. I remember the first time I saw it, I was very lost, very confused. But I got the hang of it now. But regardless, it would be a lot easier to use your graphing calculator. Okay, so I think that's all I have to say about polar coordinates for now. We talked about how y equals r sine theta. We talked about how x equals r cosine theta. We talked about how to convert from polar to rectangular and rectangular to polar. We talked about the formula tangent theta equals y over x. And how instead of the x and y coordinates that we're all used to, polar coordinates use the distance between the origin and the point and the angle between, in between the right and the axes. So, and we talked about the relationship between the two. I already mentioned that. And we talked about how there are so many different ways to represent one single point as polar coordinates, whereas there's only one way to represent a point in rectangular coordinates. Okay, we talked about a lot. I hope you learned something. And the polar coordinates portion of the test is not a majority, so don't freak out, but it is good to understand what polar coordinates are all about, just in case you encounter a question like that. So I think that's it for this video, and don't forget to stay curious.